Hey Colton,
Hey Derek.
would you like to learn some integration?
Sure.
Alright, well let's look at this. This is an integration symbol.
Okay.
It goes before a function.
All right.
It's the process of getting an antiderivative.
All right.
So let's take a look at one.
Okay.
First, there's a few things that you're going to have to know before you solve this problem.
What's that?
First, when you have an x on an integration problem, you add 1 to the exponent and divide by that number.
All right.
And, see this 3 right here?
Yes.
You're going to add an x to the end of that.
Okay.
And since it's an antiderivative, you also have to apply a constant at the end of a problem. So let's look at how that's worked.
Okay.
Here is the work shown. So there's a 1. It starts out with a 1, and you add an exponent, and you divide by that number.
All right.
You added an x to the 3,
Okay.
and added a constant.
All right.
That's the basics of integrals.
Oh my God! Thank you.
No problem. Colton, where are you?
I'm right here, boss.
How you doing, Colton?
Great.
Are you ready to learn about definite integrals?
Only if you want me to.
Alright, I want you to.
Okay.
Alright, a definite integral is a lot like those first integrals I showed you.
Yeah.
Except instead of plugging in a c at the end, we're going to find an actual number.
All right.
Alright, a definite integral shows like this. It's bounded by a and b. And you're going to take the integral from b to a, as shown here. You're going to take the derivative or the integral of the function
Okay.
and then plug in b minus the integral of the function with plugged in a.
All right.
Think we can try an example problem?
Yeah, I thought we could do that.
Alright, sounds good. So, as we see on this example problem right here,
Okay.
it says 2x minus 3. So first we're going to take the integral of that. And it's x squared minus 3x. So now we're going to plug in from b to a. And we get 4 minus 6 minus 1 minus 2.
Okay.
And that equals 0. So that means that c equals 0. Do you understand?
Yeah, I got it.
That's good.
Colton. Today we're going to learn about another exciting subject of integration, trig integrals.
Okay.
With trig integrals, you have a certain set of formulas you use to solve all the problems. Here they are.
All right.
Now, a basic trig integration problem will look as follows.
All right. What do you do from there?
To solve this is very simple. All you will do is look at your formula sheet, determine which ones you need to switch and replace, and just write down the answer. So the answer to this problem would turn into this.
That's so easy.
Don't forget to add your constant like Derek told you.
Hey Colton,
Hey.
today we're going to learn about trapezoidal and Simpson's rule.
Couldn't see that.
Here's the formula for a trapezoidal rule.
There you go.
All right. Here's an example. The
Oh.
integral from 0 to 2 of x squared. Oh,
Yep.
it's
Move your
all right.
hand.
Up.
Move your hand. There you
Oh.
go. Explain.
All right. So you take the integral right there, there, then use the formula to get your answer, which is 5/3. Here is the formula for Simpson's rule. See that, Colton?
Yep, I see that.
All right. Here is an example. The integral from 0 to 2 of x. Using your formula, you get 4/3. That is trapezoidal and Simpson's rule.
That is really easy.
All right.
Colton, another application of integration is particular solution. With particular solution, with your given integral problem, you are also given an initial condition. Initial condition will be given in this form.
Okay.
Say, for example, we have this problem with this initial condition. The first step in the solving this problem will be as follows. First, take your integral, which is this, and then plug in your initial condition, which should look like this.
Okay.
Once your initial condition is plugged in and solved for, solve for C. With this, you can see that C equals 2/3. So then, after you have your C, plug it back into your original equation, and there's your final answer. That's how you solve for a particular solution, Colton.
That's so easy.
I know.
Hi, it's Colton Stewarts.
Hey, Colton.
How you doing?
I'm good.
Okay.
We're going to learn about more integration now.
All right.
This time, substitution.
Okay.
Some problems can't be solved like normal, so you have to
Alright.
substitute.
Okay.
Example of a problem, I guess, is like follows.
Okay.
When you decide what to substitute, you show it as u equals.
All right.
In this problem, we're going to substitute x plus 1.
Okay.
This is shown as u equals x plus 1.
Okay.
Once you have that, you got to solve for du.
Alright.
Simply take the derivative of u.
Okay.
In this case, it's just du equals dx.
Okay.
Once you have that, plug it into your equation.
All right.
So now your problem should look like so.
Okay.
Take the integral, so it should be 1/3 u to the third plus c.
Okay.
Plug back in your u, and you'll have your final answer.
Okay.
There you go. That's all it is substitution.
That's really easy.
I know.
Hey Colton, are
Hey.
you ready to learn about the first and second fundamental theorem of integrals?
I guess so.
Well, I got some good news.
What's
The
that?
first fundamental theorem is almost identical to definite integrals.
Okay.
So you're just going to do the same steps for those. For the sake of time, I'm not going to go back over it. Alright, now the second fundamental theorem is a little bit different because it's like a definite integral, except it takes with relation to x. The function df of t, alright, with relation to x. Okay, let's take a look at a problem.
Okay.
If you were taking the integral of t squared in relation to x, you would go about plugging in the x, and your answer would be x squared. X squared. Is that easy?
Yeah, it's really easy.
Okay, I'm glad.
Hey, Evan.
Hey, Golden.
How you doing?
Good.
That's great.
All right. This is mean value theorem, or also called average value.
Okay.
Here is the formula for mean value theorem.
All right.
Here is an example problem. What you do is put 1 over b minus a, the integral from 0 to 1 of 1 dx. After doing this, you get 1 times x, still from the interval 0 to 1.
All right. That's not that hard.
After this, you get 1 minus 0, which is
1.
yeah. All right, it's over.